Hi everyone, I am JULKA. Today in Indefinite Integral Part 12, we'll talk about how to integrate quadratic function. In this part, we will use three formulas. Integration of in the root of a square minus x square respect to x is x upon 2 in the root of a square minus x square plus a square by 2 sine inverse x upon a plus c. Next, integration of in the root of x square plus a square respect to x is x upon 2 in the root of x square plus a square by 2 log in mod x plus in the root of x square plus a square plus c. And integration of in the root of x square minus a square respect to x is x upon 2 in the root of x square minus a square by 2 log in mod x plus in the root of x square minus a square plus c. Now first we prove first formula. In the root of a square minus x square respect to x. We'll solve this question using by parts. Take quotient equals to y and root a square minus x square as a first function and 1 as second function. First function as it is, integration second is x minus derivative first is 1 upon 2 in the root of a square minus x square into minus 2x and the integration second is x. Now I equals to x in the root of a square minus x square minus x square divided by the root of a square minus x square. So plus a square minus a square. Now when we divide this part into two parts, so we have I equals to x in the root of a square minus x square minus a square minus x square divided by in the root of a square minus x square plus a square dx divided by in the root of a square minus x square. After simplification, we'll get I equals to x in the root of a square minus x square minus in root of a square minus x square respect to x plus a square integration of dx divided by the root of a square minus x square. When quotient repeat, put equals to I. And the integration of the last part is sine inverse x upon a. Now I plus I is 2i. So 2i equals to x in the root of a square minus x square plus a square sine inverse x upon a. Divide by 2 both sides and we will get I equals to x upon 2 in the root of a square minus x square plus a square by 2 sine inverse x upon a plus c. Now we'll use application of this formulas. First example, integration of in the root of x square plus 4. We can write this way in the root of x square plus 2 square. Now we'll use the formula of x square plus a square in root. It is x upon 2 in the root of x square plus a square by 2 log in mod x plus in the root of x square plus a square plus c. And here a is 2. And after simplification we will get x upon 2 in the root of x square plus 4 plus 2 log in mod x plus in the root of x square plus 4 plus c. Next point, whenever in root we have quadratic, first we make perfect square of it and then we solve using formula. We can explain this by quotient. Integration of in the root of 8 minus 2x minus x square. To make perfect square, first we take coefficient of x square common, but we take here minus common in root because we cannot take negative common outside the root. So it is minus in x square plus 2x minus 8. To make perfect square, plus 1 minus 1, and when we simplify this, it is minus in bracket x plus 1 whole square minus 9. It is 3 square minus x plus 1 whole square in root. Here we use the formula of a square minus x square. It is x by 2 in the root of a square minus x square plus a square by 2 sine inverse x upon a plus c. Here x is x plus 1 and a is 3. So after simplification we have answer x plus 1 upon 2 in the root of 8 minus 2x minus x square plus 9 by 2 sine inverse x plus 1 upon 3 plus c. Next point, whenever we have a quotient in the form of px plus q multiplied by the root of ax square plus bx plus c and px plus q is not equal to derivative of ax square plus bx plus c, then we assume px plus q equals to a times of derivative of ax square plus bx plus c plus b. We can explain with the help of an example. We have a quotient x minus 1 in the root of x square minus 8x plus 25. X minus 1 is not equal to derivative of x square minus 8x plus 25. So we let x minus 1 equals to a times of derivative of x square minus 8x plus 25 is 2x minus 8 plus b. When we comparing the coefficient of x and x naught both sides, we will get 2a equals to 1 and minus 8a plus b equals to minus 1. So a equals to half and b equals to 3. So x minus 1 equals to half of 2x minus 8 plus 3. Now replace the value of x minus 1 in the question and we will get half 2x minus 8 plus 3 whole multiplied by the root of x square minus 8x plus 25 dx. When we divide question into two parts, the first part is 1 by 2, 2x minus 8 multiplied by the root of 8x square minus 8x plus 25, and the second part is 3 times of in the root of x square minus 8x plus 25. We take it is I1 plus I2. First we solve first part. I1 equals to half of 2x minus 8 multiplied by the root of x square minus 8x plus 25. First we put x square minus 8x plus 25 equals to t. Derivative with respect to x both sides. So 2x minus 8 dx equals to dt. Replace 2x minus 8 dx by dt and the root of x square minus 8x plus 25 by t, and the integration is half into t raised to power 3 by 2 upon 3 by 2 plus c1. After putting the value of t, we have answer 1 by 3 x square minus 8x plus 25 raised to power 3 by 2 plus c1. Second part, I2 equals to 3 times the root of x square minus 8x plus 25. To make perfect square, we will add 16 and subtract 16. It is 3 times of in root x plus x minus 4 whole square plus 9. And we can write this way. In the root of x minus 4 whole square plus 3 square. And we'll use the formula of x square plus a square, which is x upon 2 in the root of x square plus a square by 2 log in mod x plus in the root of x square plus a square plus c2. Now what is I1 plus I2? Now we'll add both. Answer is 1 by 3 x square minus 8x plus 25 raised to the power 3 by 2 plus 3 times of x minus 4 upon 2 in root x square minus 8x plus 25 plus 9 by 2 log in mod x minus 4 plus in root x square minus 8x plus 25 plus c, where c equals to c1 plus c2.